Okay, so here we go, A2 Mechanics, Chapter 7.4, second lesson on this section with the second starter. This should be a fairly quick one, but we'll just have a go. So the question looks something like this. A smooth plane, so we've got a smooth plane, angle of 20 degrees to horizontal, with a force pushing our particle, which is 10 kilograms. So we've got 10g acting downwards in that direction at an angle of 40 degrees to the plane, and it's pushing with a force of 20 newtons. Find the acceleration. So, have a quick go at that. While you pause this, and then obviously when you turn it back on, the answer will follow. So here we are with the answer. Standard approach. Since the plane is smooth, well, let's just put our other forces on the diagram. We're going to have a normal reaction, R to the plane, but there is no friction. So nothing parallel to the plane, because the plane is smooth. So we're just going to apply, we're asked for the acceleration. So if we're asked for acceleration, that's a good indication that we're going to be using N2. So we're going to apply N2 parallel and up the plane. To do that, we've got to break our force of 20 newtons down into its components. So we've got a component parallel to the plane. So parallel to the plane, we've got 20 cos of 40, and perpendicular to the plane, we've got, I've drawn that on in the wrong direction. I've got to add up to create the hypotenuse. We've got 20 sine of 40 opposite the known angle. Okay, if we're applying N2 up the plane, we also need to do the weight. It has two components, a component perpendicular to the plane. If this is 20 degrees down here, then this angle in here will also be 20 degrees. So this force is next to the angle. So we've got 10g next to the angle cos of 20. Okay, opposite the angle, again, these two forces adding up to make the hypotenuse of 10g, we get 10g opposite the angle, so sine of 20 degrees. Okay, so we are going to apply N2 parallel to the plane. So parallel to the plane, that's what we're doing. So that's that component and that component are parallel to the plane. So we get, if we're working up, 20 cos of 40 minus 10g, let's change the colour. Sorry, so we're writing in our usual black. Okay, so we've got up the plane 20 cos of 40 minus 10g sine of 20 is equal to, the mass was 10, A. So A is equal to, divide through by 10, 2 cos of 40 minus g sine of 20. Type it in the calculator. It's going to be, let's just see, 2 cos 40 minus 9.8, or g sine of 20 equals negative 1.8. negative 1.8 meters per second. Okay, now that tells us that it's therefore, so therefore accelerating down the plane. Just not as quickly as it would have done if we hadn't put the 20 newtons force on it. Okay, I hope you got that right, and starter 3 will be there for you to watch when I've done the video. Okay, cheers guys.